Assalamu alaikum class, and this is the chapter 5 review we will be doing. Please feel free to see this as many times as you want. It'll be helping you out with the chapter 5 test and the midterm. So first, let's start with the triangle. The triangle is what we've been discussing for the last two chapters. There's a few important things about a triangle that you need to remember. The first thing is if I took angle A, angle B, and angle C and add them together, you realize a triangle has 180 degrees inside of it at all times. The second thing is the area. The area of a triangle is one half the base times the height. So let's show you the base would be something like this, and the height would be it'd be the altitude is which we'll be discussing soon. So one half base times height is how they got that. The way they actually got this, I explained this in class, is if you took a rectangle, let's see that exactly right there, and they said that if you took exactly half that rectangle's distance, you would get that triangle. And I can actually probably show you in Starboard. It would actually make sense. Let me see if I can do a red triangle this time. So this red triangle, let me see. All right, so if I move, well, not this. Let's see if I can move this. I guess I got too carried away. You cannot show in Starboard. But if I were able to rotate it, the top vertex, you'll see that no matter what, if I move this top vertex here or here, if I move to the left or right, it will still take the same area. And the last important thing to do is to find the sides of a triangle. It's called the Pythagorean theorem, and you guys all seem to have known this. A squared plus b squared equals c squared. So in this case, if I took a triangle, let me scroll down, it's getting pretty messy up there. If I were to take a triangle and I gave you two sides of it, a, B, and C, you should be able to find a third side of it just by doing A squared plus B squared equals C squared being the longest distance. So now we got that taken care of. Let's get on to the actual segment, chapter 5. So we went over a few things. We went over first a mid segment. So I don't want you to forget that term mid segment. It comes up quite a bit. So right over here is a mid segment. What that is that's halfway distance between here and halfway distance between here and here, and they're connected. So what's significant about this is if I take that mid segment and I take this area right here and I compare them, you will see that the mid segment, and let's label it A, and let's label the actual area of the triangle B, that you're going to notice two things, that A um, is equal to half of B. So let me do this. A is equal to 1/2 of B. So whatever size this blue right here is, B, exactly half of that is going to be the mid segment A. Another thing is that A is parallel to B. So I can just go ahead and put these little lines here to tell you that they're parallel. So that's the big thing about that. The mid segments, if I were to make a mid segment for this triangle, it would make its own little triangle inside, and each area for this, for instance, this area right here would be half of this area over here. So pretty nifty. Let's work on the next major topic, which we're talking about is perpendicular bisectors. So the thing is, if I start with a line segment, we have to start with a line segment. So points where it starts and a point where it ends. So of course, we're going to label it A and B. And if we're talking about perpendicular bisector, so think about the word bisect is going exactly halfway through. So these are going to be equal. The second word is perpendicular. So it's perpendicular bisectors. That tells you it's exactly at 90 degrees. So what's significant about a perpendicular bisector? If I took a perpendicular bisector, for instance, and I took a point here, so let's take a line, blue line, and if I connected these points from here to here, and here the end of the segments, there's something significant about these. They're going to equal each other. So all of a sudden, if I said this is, for instance, 3x plus 3, and this is 5x minus 5, since you know they're congruent to each other, you can just set them equal to each other. 3x plus 3 equals 5x minus 5, and solve for x. Now remember, when I ask you this, you have to figure out if you're solving for x or you're finding out the area of this actual line right here. So that makes sense. But let's do the converse of that. The converse states that if I had this line, and let me get rid of this portion. Let's see if I can. And I don't think it will let me get rid of this. There we go. So let's just get rid of this. Or let's actually, excuse me, move this right over here. So we have a line now. Let's make this. We're going all red and blue today. So we have this line, and the question states that we have a perpendicular bisector. So it is bisecting perpendicularly. And then we give you this point, I'm going to highlight it in pink now, right over here. And we're saying that the distance from here and here are equal. So all the information we're given right now. Now from this converse, we're asked this line on the bottom, the only one line here, we don't know if it connects and it goes all the way straight up to here and continues through here or not. But the converse of the perpendicular bisector rule says that yes, if I was given the information these are equal and it is a perpendicular bisector, then it will definitely be going through this point. So that is the inverse of that rule. Now, when we talk about perpendicular bisectors, let's take a triangle. And let's have some perpendicular bisectors in here. So bisecting exactly halfway. So let me use the blue line. Bisecting exactly halfway, probably like that. And of course, I'm eyeballing these and that. And you'll see that the only time my eyeball that is actually went through the median and hit the vertex was this one, but it doesn't necessarily have to hit the vertex. All you have to do is make sure there's 90 degrees and it splits the side in half. So 90 degrees splits this side and this side in half. And once again, 90 degrees and splits this side and this side in half. Excuse me. So what we have here is a point in between, the point of concurrency, the concurrent point. What we call this? When the perpendicular bisector terms, we call this the circumcenter. See the word here? Center. I think I had an extra letter here. So see the word here? Circum. So think about circ, and it's the beginning of circle. And so you remember that what's significant about this is if I drew this correctly, and we will find out. Well, I guess we will, let me see. Okay. So if I drew this correctly, and it was not drawn correctly, of course, because I just eyeballed it. All right. Well, had it been drawn correctly and I wasn't eyeballing it, and I was actually using my compass and protractor, all 3 points here and here and here would have landed so perfectly inside the circle. And this is the experiment we did when we cut off little circles and then you fold it in half to find the perpendicular bisectors. So that's the main important part. The second thing is angle bisectors. So if we took a triangle again, and we made a line exactly halfway through. So let's make it exactly halfway through so that this and this were equal. And we did the same exact thing exactly halfway through. So then this angle and this angle we go. And we're bisecting each of these angles. And so this and this would be equal. We'd end up with a point right in between, the point of concurrency. Now we gave this point of concurrency a name too. We call this the incenter. So once again, you're seeing the word center, right? So you're thinking a circle. So let's see if somehow we can get lucky with this one. Oh, not bad. It was a lot closer. So the incenter would go right over there, and it would tell you that the points from here to the point. Oh, let me see. Let me get rid of the circle. The point from here to the point it touches a circle here, or the point from the concurrent port to the point it touches a circle here, or the point from here to here where it touches a circle. All of them are the exact same. All right. The third big thing is medians. Right, and I'll wait till the second video starts to start medians.